Hello everyone, welcome to this class. We're going to continue our class on logarithm. There's something I want us to take note of. Read this by saying the result obtained when calculating 4 figure tables are accurate only to the first 3 figures. The fourth digit is not likely to be accurate and is used for rounding off a result to 3 significant figures. 3-figure accuracy is sufficient for most practical purposes. So what they're trying to say here is that when you finish solving with your 4-figure table, the 3 significant figures are mostly the most accurate. The rest, it will be close, but you see, that's why you see some of the answers we get. You notice that we'll have a little slight changes. So 3 significant figure means the first 3 digits, not 3 decimal places. Take note of that. The first 3 digits will be the same, while the rest will change. And if you check all the examples we've done so far, you will also notice a similar pattern. Where all those examples we did, look at the calculator, see that these are 3, see that they are the same. Where all those other ones that we did, and when we solve for it, we'll look for the calculator value. Okay, look at this one. See what we got with our 4-figure table. This is the calculator value. Notice that the first 3 figures are the same. You see that from the third one it has started changing. Let me look for another one. Here, look at what we got here. This is what we go with our 4-figure table. This is what we go with our calculator. You see, notice that the first 3 figure is the same. From here now it started changing. 6, yes, even though they are still very close. But notice that the changes start occurring from the 3rd figure. So that's what this is trying to say. So in this class, we're going to deal with logarithm with word problem. Like you are given a problem, but you're going to solve it with your normal calculation. You are being told to use your 4-figure table to solve them. Let's solve the first one. Say calculate to 3 significant figures the area of a flat circular washer 6.84 cm in diameter with a hole of 2.96 cm in diameter. Take your logarithm of pi to be 0.4971. Now let's say this is a washer. You know how a washer used to be. There will be a hole. So they're trying to say that the diameter from here to here is 6 point. Okay, let me say this diameter. Sorry, not this one is radius. Is 6.84, while this small circle inside, the diameter is 2.96 or in cm. Now when you want to find this area of this part, let me call it the shaded part. Let me shade this small. Simply find the area of this small circle, find the area of the big circle, then you subtract the area of the small circle from the big circle. You will now find the area of the shaded region. And what is the area of a circle? Pi r squared. But here we are given the diameter, not the radius. So the area of the big circle will simply means if you want to solve for area of a circle using the diameter, it will be pi d over 2, because radius is diameter divided by 2 or square. But we are not solving. Let's first convert this radius. First, the radius of the big circle, let me call it b, to be 6.84 over 2, which will give me 3.42 cm. While the radius of the smaller circle will be 2.96 over 2, which will give me 1.84 cm. So my area will now be something like pi times 3.42 squared, right? Minus another pi again times 1.48 squared. So the next thing we are going to do is, like term is pi, so I have pi into 3.42 all squared minus 1.48 all squared. Now this, there's what we call the difference of 2 squared. What does it mean? It means that when you have x squared minus y squared, you can express it as s plus y all multiplied by y. Sorry, this is x x minus y. This one that has the minus, so this one will be at this point. It's called the difference of two squares. Let me write it here. X plus y, x minus y. So whatever you get here is same thing you get here. So you can see that these are values looking like the difference of two squares. So I can change it to pi into 342 minus 1.48 multiplied by 342 plus 1.48. Are we together? When you subtract this, you have pi, this subtracted by, let me say this subtract from this will give you 1.94 times this plus this will give you 4.9. Now this is what we are going to now apply logarithm on. Remember our laws of logarithm. When you have something like this, you change it to the logarithm form. When you change it to the logarithm form, the next thing you are going to do is to do what? To add. Then you now find the anti-logarithm. So the logarithm of pi was given to us that we should use this. So this is 0.4971, right? Then the logarithm of 1.9. I'm not going to show the example. I'm not going to show the table here, so our class will be short. But we've already, from our previous class, know how to look out for the number from the table. Just find the characteristics. Then you now do 19 under 4. So if you do that, you will get characteristics of this one is 0, obviously 0.2878. While the logarithm of this, find the characteristics of 49 under 0, which should give us 0.6902. Because here is multiplication, we apply our law of logarithm. We are going to add this, and when we add it, we'll get 1.4751. So we'll now find the anti-logarithm of this. When we find the anti-logarithm, now let me show the full working for anti-logarithm. I will leave the characteristics. I'll look for 0.47 under 5 difference 1. This is 47 under 5 to be 2985. 2985 difference 1. 2985, right? Difference 1, which is still 1. So I'll just add 1 here. I have 2986. So this is my characteristics. I'll just do 2.986 times 10 raised to power 1, which will give you 29.86 as your final answer. So to confirm this is our answer, okay, I'll put cm squared because it's in cm. To confirm this our answer, you can just solve this direct. Where we jump to step to know if you are getting the same answer. And remember what they said, the three significant figure, which is the first three number, must give you exactly the same answer. So what does this word problem do? What it does is that you are given a word problem which on a norm, this is how you should have solved it. When you reach here, you punch your calculator and get your answer. But we are being told to apply logarithm on it. Instead of us to solve it with our normal usual fashion, we now convert to logarithm and apply the laws of logarithm to it. Then we find the anti-logarithm and get your answer. Let's solve another example. So the first thing we're going to solve is exercise 1M number 3. They said calculate the volume of a cube excuse me, of edge 8.24 cm. Now what's the volume of a cube? Simply means L cube. It is length times height times breadth, but since cube has all sides equal, we just call it L cube. Any of them you have cube of that. So our L in this case is 8.24. So our volume is cm 8.24 all raised to power 3 in cm cube. So this is what we are solving for. and this is where we apply our law of logarithm. So applying our law of logarithm, log 8.24 is simply, our characteristics here is what? 0. Already now we need to get characteristics, just change to standard form onto job step. So the next thing is check 82 under 4. 82 under 4, this is 4. 9159. 9159. Right? According to our law of logarithm, when a number is raised to power, what do we do? Multiply it by that power. So it will be, let me say something like 0.9159 times 3. I'll get 2.7477. So I'll now look for the antilog of this. So log of 2.7477. Remember, you keep your characteristics and solve for your matrix. I'll look for dot 74 under 7 difference 7. So go to our antilogarithm table. This is 74 under 7, which is 5585. Difference 7 is 9. So I'll write it out. 5585 and 9. I'll have 4, carry 1, put here, 9, 5, 5. This is my mantissa, right? So my real answer will now be 5.594 times 10 raised power what? The characteristics. So the answer will now be 12559.4 cm cube. So you can solve this with your normal calculator to see if you are getting this answer. So what does this mean? As I said before, it's just solving your normal question you know how to solve for. But instead of you to solve it with your normal conventional mathematics, you have to convert to logarithm, apply the laws of logarithm, and after that you change to anti-logarithm to get the answer. Just going through a long process. So let's solve one more example. I think I missed something here. From the question, we have been told to give our answer to 3 significant figure. So this, changing this to 3 significant figures is 1, 2, 3. The next one is not up to 5, so we'll leave it. It will be 559 cm cube. This is your answer. So let's solve the next question. The same exercise 1M, number 10. It says a room contains air. It contains 156.1 meter cube of air if the room is 8.31 meter long and 5.72 meter wide. Calculate the height. So what are you trying to say? When they say that the room contains this, that's where word problem comes. You use your logic to understand what they are saying. It means that the volume of the room is 156.1 because the volume is the air inside the room. So I will say volume is 156.1 meter cube. Now they now give us that if the room is this long, then the length is 8.31 meter long and the width is 5.72 meter. So what is the height? Height is what we are looking for, and we all know that the volume of a room is simply length times width times height. Since we cannot find the height will now be volume divided by length divided times width. So this is what we are going to look for. So if we are to put this, our height will now be 156.1 all divided by 8.31 times 5.72. This is what we are looking for. So the next thing is that we are going to now convert all these things to logarithm and apply the law of logarithm to it, and after that anti-logarithm. So this is what we are looking for, the height. I copied it from the other page here so we can see it. Now I've already changed all this number to their logarithm form. No using the 4-figure table. I've already said it so many times in this class. You can on your own do it to know if you are getting the same answer as I am. So the law of logarithm, this is the same as saying 156.1 divided by 831 times 572. So now that I've converted it to logarithm, the laws will change. Division will be minus and multiplication will be plus. So it will be, this is it, 2.193. Because of this, logarithm of this is that, minus, in bracket, logarithm of 8.31 is that 0.9196, plus logarithm of this is that 0.7574. So when you add this, you have 2.193 minus 1.677. So when you now subtract, we'll have this minus this, you have 0.516. You now look for the anti-logarithm. So you look for 0.51 under 6. This is 51 under 6 to give you 32.81. So let me say anti-log of 0.516. So I'm getting the answer is 51 under 6, 3281. This 3281 is to get the real value, and now add the characteristics. It will give me 3.281 times 10 raised to the power 0, which is 3.281. So this is the anti-log. I'll put it here, 3.281. So this is your final answer. It will be in meter. So hope you understand what we did. We calculated for the height of the room. This is the volume, this is the length, this is the width. This is the formula to get the height. So for us to solve it the normal way, we now use logarithm, convert to log, and apply the law of logarithm where division turn to minus, while multiplication turn to plus. After solving, we get this. We now look for the anti-log of this and get that, and that is our final answer. Remember, we have been told to put it in 3 significant figures. So changing this to 3 significant figures will give me 1, 2, 3. 1 is not up to 5, so I'll throw it away. So my final answer will be H 3.28 meter. This is my final answer. So with this, we are done with word problem involving logarithm. It's just very simple. Here we did the ones that deal more with the ones that deal more with multiplication and division. Just translate the word problem. After translating it, find the formula. When you write out the formula, in this case, it is cube. Now change to logarithm and apply the law of logarithm. After you get the answer in logarithm form, change to anti-logarithm, and you find your final answer. See you in the next class. Thank you.